traditional programming happens. It's all about it's all about data mixing up with your program, going inside a compiler, which gives you the output. But what's interesting about machine learning? Um, what's the unique part about machine learning is that we have the data and we have this output also, where the machine learning algorithm tries to, like, as one of you said right now, like, whether you can even tell it that it identifies a pattern or something, or it figures out a particular function or something, and it gives us a model, or it gives us a program where this particular program can be used in future to predict new cases. So inside a particular machine learning algorithm, we are feeding in a kind of data, where this data is used to train that machine learning algorithm into a particular output, where this output will be used to predict future cases. So I guess that part is okay. So if we look at this particular thing which we saw right now in terms of functions, so can anyone tell me what a function is? Come on, guys. I just had two enthusiastic people who just answered right now. Can anyone tell what function is?
which can be used to perform a single little task.
Okay. It is used to perform a single task. That's correct. In basically, yeah, that's correct. So is there any other explanations which you guys can give for what a function is exactly?
It's a block of code which, like, when we write something, we don't have to type it again and again. It just calls, we can call a function and it will do our stuff.
Cool, cool. That's correct. Okay, let's think in terms of our 10th grade. Okay, let's not think as engineers right now. Let's think in term of 10th grade. So, in term of 10th grade, if we look at this particular point, a function, if you just take a particular function as f of x, so this function can be anything, right? Like x plus y can be a function, where you can just say that if x is equal to 1 and y is equal to 2, what does this f of x return actually?
3.
F of x returns 3. So this f of x right now is a simple addition function, isn't it?
Yeah.
So when we looked into the terms of traditional programming, what just happened was you just wrote down a big piece of function where it was hard coded to do a certain job, like how we just saw, like where a function performed a simple addition. But in case of machine learning, what we are going to do is that we are going to feed in data into a particular algorithm, where this algorithm returns us a function. So in this particular function can be further used when a input goes inside and a prediction comes outside. So basically what we are trying to do at the end of the day, while we are performing a machine learning training, or even in the case of a deep learning training, or whatever it is, like what we are doing is that we are just trying to figure out this function. So I hope looking machine learning models in terms of function won't be really new stuff henceforth. So as of now, you can come up to a conclusion that the end part of a machine learning process is to figure out a function. So proceeding into the next part now. So, what are these terms actually? Wherever we go right now in the booming tech field, we see all these stuff, right? Like machine learning, deep learning, reinforcement learning. It almost excites us like always. Like, yeah. So have you guys ever been in a really confused state, like where should I start? Should I do deep learning or should I do machine learning? Have you guys been in that state before, guys? Just saw someone turning on their mic right now. Okay, guys, if you're not gonna speak, we're not gonna proceed.
No, we had no problem. Initially, like when we started, there was some problems, but now it's like we are able to do something.
Okay, fine. So it's just all branches of it's just all offshoots and branches of complex mathematics. That's how we're gonna look at this particular point. Like when we look at the ML part, it's just complex maths, and when we go into deep learning, it's just more complex math. And regarding reinforcement learning, it's off track of right now. We don't need to discuss about that. So just let's yeah, this was also one particular part where most of our candidates gave us really wrong answers during the interview, which was like supervised machine learning and unsupervised machine learning. So can okay, right now let's clear it off. So can any one of you guys tell me what is a supervised machine learning?
In which like outputs are already given, we just have to predict. In unsupervised, we have to like make out some of the outputs
Okay,
or
okay,
is this.
okay, cool. Can anyone else build upon that particular answer, or if you guys have a different form of looking at it?
Well, we use label data set to train an algorithm,
Okay,
and then we predict the data outcomes on the basis of the label and of the training.
exactly. So cool. So when we had conversations with you guys, so what we wanted to clear out right now was what are features and what are labels. Okay, so basically taking this as your particular data column or something. Okay, let's come back to this later. So, guys, looking into the entire learning process of supervised machine learning, what we do is that we first figure out our data set. And from this data set, we identify something called features and we identify something called labels, where these features and labels are sent into a learning process. So first we identify our data set. Next, after doing certain processes with our data set, we separate it into features and labels. And once we have these features and labels, we put it through certain learning process. And once the learning process is done, we get our final model. So this final model is the end point of the entire learning process. So you can name it as learning process also, and you can either say it as modeling also. Both the term works in as as far as now it concerned, like both the term works. Like you can name it as modeling or you can tell it as learning process. So yeah, the outcome of the learning process is the model. So but you can ask me a question that what is features and what is labels right now. So looking into the aspect of what is features and what is labels, like let's just take a data set where we are looking into looking whether a mango is ripe or raw. So just let's just name this data set as mango. So here we have details of the mango, like the color of the mango and the weight of the mango. And here we have whether the mango is raw, ripen, or all these stuff. So this particular information which is used to which is used to exactly categorize the uh, categorize the data, or which serves as the target data, we call it as the label. And this particular data, where which is like used as inputs, we call this as the features. So when you look at features and labels, so that is one more example right now. So we can even look into this particular part where like we can say, um, like if you go into a particular what's that, into a particular um, case where like we're trying to figure out the daily average of a person who's gonna buy apples, mangoes, and oranges, and here is gonna be the price. And every day he has certain inputs inside his data, and one day his price is going to be 120 rupees, and the next day his price is going to be 130, and it's again going to be 110, 100, 90, and all these stuff. And this stuff is gonna be like the number of apples. One day he's gonna get 3 apples, 4 mangoes, and 5 oranges. Or the next day he's gonna get 6 apples, 7 mangoes, and 8 oranges. And correspondingly, he has the price. So can anyone tell me what's gonna be the feature here and what's gonna be the label here?
Apple, mango, and oranges, I think, will be the features.
Okay, what will be the label?
Price.
Price.
Okay, the price will be the label. That's correct. So here, whatever you call as label will be the target, in the sense, with the information of the number of fruits, number of apple, mangoes, and oranges, we will be trying to find out the price. And this relation or this function will be figured out using a ML model. Cool, guys? Anyone have any doubt till this particular part?
Yes.
No doubt.
Guys, it's really fine if you have doubts right now, like you can just shoot it off. Okay, how many of you really understood till now? Can you raise your hands? How many of you have no problem? Yeah, cool. So proceeding further, this is what we called as like features and labels right now. So if you wonder what would happen after training a model, like in case of a prediction phase, so what would happen during that particular time? We can say that during the prediction phase, we can have a color of a mango, and we can have what's that? The size of a mango. So let the color be something like yellow, and the size of the mango, let's represent it by an index of 5. And what happens is that these this particular color and then this particular size will be considered as features, and this particular feature will be sent into our like this particular model
तो
which we
तेरा ही
have
होगा, हमें नहीं
extracted
पता.
from the learning process. Did you guys just remember we talked about sending our data set, breaking it down into features and labels, putting it through a learning process, and extracting a model out of it? So what happens is that
मैं
this new
देखे
instance is
जाऊँगा.
fed into this particular model, where this model generates out a prediction right now. So this is how the flow goes when it comes to the term of prediction.
क्या है?
So since here we have two features. First feature will be the color of a mango, and the second feature will be the weight of a mango. Can we represent it in a two-dimensional graph? Is it possible to represent it in a two-dimensional graph like how we have done it here right now?
Yeah.
So we have just and okay, let the x-axis be the weight of the mangoes and y-axis be the color of the mangoes, and all these small points, let it be all the test cases, like let it be points with coordinates as color and weight, color and weight, and color and weight, and etc. So right now, what was our initial goal? What was our initial target regarding the mango data set? What was our targets, like what was the labels? It was going to figure
Price,
out where, yeah, come on, someone just spoke right now.
price,
Ripe or raw, right? We have to figure out whether a particular mango is we have to just figure out whether a particular mango is in a ripe state or in a raw state. So what if we just figure out machine using the ML techniques and tricks? We have just got a straight line. So what this straight line does? Can anyone have an intuitive approach of like what this straight line exactly does in our feature space? It's really fine, guys. Like whatever strikes in your head, it's like really fine. You can just shoot it off. Like using machine learning techniques, we have just fed this color weight combination inside a machine learning algorithm, and the machine learning algorithm has given us a straight line. Can anyone tell me what this straight line is going to exactly do in this feature space?
It will give the expected output.
Yeah, cool. It will give the expected output. But how, okay, Aryan, I guess you just now joined. So making it clear to you, this feature space consists of features regarding a mango with its color and weight. So we are just gonna try to classify the particular a particular point, whether if it's gonna be a raw mango or a ripe mango. Now, can you guys tell me what this exact line is gonna do regarding our feature space? Cool. So what this line is going to exactly do in our feature spaces, it's going to separate our data set in a case where everything which is above this line is going to be raw mango, and everything which is going to be below this line are going to be ripe mangoes. Works? So can, is it possible to create such a machine learning model? It already exists, right? We can create such a model. Like we can create such a model for classification purpose. So what we have just got right now is that only using the features we were, if nothing else was required, right? Only using the coordinates of color of a mango and weight of a mango, we were able to create a line where it was able to divide the entire feature space into raw or ripe. So we have just got these this particular line. Okay. So guys, can you tell me, using this particular line, will we be able to predict in future if any point comes? If the point is above the line, we will name it as raw, and if the point is below the line, we will name it as ripe. Is it possible? It's very much possible, right?
Yeah.
It's very much possible that if we have a new point in future, like if we say it has this much color and this much weight, and the point gets plotted over here, new point, and we clearly say that the point is like above the line, therefore it's raw. What if we have a new point where they say that it has this much color and this much weight, and this particular point is below the line, so we just name it that the particular point is ripe. So this particular line which we have got right now, what is this particular line in terms of machine learning? Can anyone just shoot off that particular point? This particular line which we have got right now, which acts as a predictor in future also, what is this exact line called? Do you guys have a intuition of it?
Linear regression.
Slow.
Okay, that can be like those words you will come across right now. That's good try. So what this line is exactly, guys? Come on, guys. I just saw a few answers coming up for the previous questions. What can this line be called exactly?
Line of best fit.
Okay, line of best fit. Line of best fit is a really good answer. So this particular line can be called as line of best fit, as Animesh told. Or basically, guys, what did I just tell you before we just started off? A data set is separated into features and labels. It's put through a learning process. And what is derived at the end? The model is derived at the end. So this particular straight line, which we have got for the simple data of color and weight, this particular straight line is the model. It's so simple. So we have just got a model which will be able to classify our simple color and weight based mango data into whether it's going to be raw or ripe. So we have just seen a linear model which is capable of classifying a particular two-dimensional data. So guys, how many of you are clear with this part till now? Abe, you have raised your hand. Do you have a doubt? Abai, do you have a doubt? Cool. So how many of you guys are cleared till this part? Can you can I have a like can you raise your hands right now? How many of you guys are clear till now? Aryan, Suryansh. Um okay. Okay. Cool, cool. So we just have a linear model which is capable of classifying a two-dimensional data. So yeah. So talking in terms of dimension. So can you guys give me an answer of what dimension is? Anyone? Guys, let's be quick. If we don't be quick in answering, we won't be able to cover a lot of stuff. So, can anyone shoot off like what is dimension exactly?
The starting and end range of the data set.
Cool. Starting and end range of the data set. That's a really intuitive answer, Parth. And anyone else?
The size it takes in an environment in
Size it.
space.
Cool. That's also a really close and really intuitive answer. That's correct. Anyone? One more answer?
Number of features.
Correct. Cool. That was exactly what I was trying to say right now. So, what's your dimension is that your number of features. So, it's going to be 1, 2, 3, 4, and 5. So, using these many features, if we are trying to predict a target. So, here the feature space will be nothing but 5. So, in machine learning terms, this will be the dimensionality. Guys, in my particular presentation, I have a lot of spelling mistakes. Kindly please ignore that. So you can just ask me that what is this r power 5 and all. Just don't care about it, but we represent dimensionality in terms of this r to the power 5. So if suppose we have just what's that? If suppose we just have like three features right now. Here the dimensionality will just change into r to the power 3. Works, guys? You just did you all guys get like what's dimensionality is exactly? It's just the number of features involved in a particular machine learning process. Can I get a like hand raise? Aditya, was it okay? The number of features. Okay. Suryansh, Krishna. Okay. So that was all the basics which we needed in terms of supervised machine learning. Coming to the part of unsupervised machine learning, can anyone tell me what how unsupervised machine learning exactly works? Not exactly works. Can you guys give me an intuitive approach of what's unsupervised machine learning? Anyone? Fast.
Labels are not present there.
Labels are not presented. Cool. Anything else?
We don't need to predict like an exact value. We need to put it in some categories.
Cool. Really nice. Cool. So, yeah, guys. While we are coming to the case of unsupervised machine learning, till now I was like crying about this particular thing, right? Feature and label. Here, this feature and label pair is strictly broken out where we don't have any labels. Our particular data set only has features. It just have features. Just imagine a data set like where we saw the case of mango classification, right? So what if the dataset just had this color of the mango and size of the mango? So what if this was the only entry? What can we derive out of this kind of data set while we pass it through a machine learning algorithm? So that process, which we call it as unsupervised machine learning, where we say that the data set do not have a supervision. Guys, we got a lot of creative answers like while we asked this question to you guys in the interview. A lot of you guys like misinterpreted the word supervision, but supervision is nothing but, in terms of data, supervision are your labels. So supervision is nothing but your labels. So unsupervised machine learning is a process while you train a machine learning algorithm over a data which doesn't have supervision, which necessarily means that your particular data doesn't have labels. So what happens when a data which doesn't have labels is put through a machine learning algorithm? It gives out clusters. So, what are clusters? Clusters are data points which are similar in nature. So, this similarity and this pattern is determined by the learning algorithms. So, I'll just make it clear what happens again. When a data which has no supervision is passed through learning algorithms, it gives us out clusters. So, when a data set, yeah, that's the thing. So okay guys, did you just get what unsupervised machine learning ka basics is, like what unsupervised machine learning is? Okay, okay. So cool. So that's the basic which we needed for unsupervised machine learning. So fine, let's come to these questions. I don't want Animesh and Naman to answer these questions. So coming to this part, given a bank customer's profile, should a loan be sanctioned or not? Is this a supervised machine learning or unsupervised machine learning?
Supervised, I think.
Why is it supervised, Aditya? Aditya?
Because we need a features here. Means the bank customers features
Hmm.
along with his name and ID.
Yeah, really true. We need his name, we need his ID, and we need some other stuff which is done by him, maybe his CIBIL score or something.
Yeah, exactly.
CIBIL score. And we need one more part. We need a label which tells us whether for this kinds of input we can grant a loan, and for another kind of input we can grant a loan, for another kind of input we cannot grant a loan, and for another kind of input we cannot grant a loan. So this kind of process where like a bank customer need to be sanctioned a loan or not can be done by a, what is this, a label which is a supervision. So this particular thing can be categorized into supervised machine learning, isn't it? So coming to next part, in a audio track, separating the singer's voice from the BGM, what can this be? Come on guys, make it quick guys, we have one more interesting part to look at. So in a particular audio track, to separate a singer's voice from the BGM. What is it exactly? Is it supervised or unsupervised?
Unsupervised.
Okay. Why do you think it's unsupervised?
Because there are two groups now. One is the background music and the other is the singer's voice.
Exactly. And we also don't know what is the background music and what's the singer's voice. We are just gonna relate the frequencies of the music in term to the patterns and relations which are gonna be similar. So on the basis of similarity, we are basically segmenting the background voice from the singer's voice. So guys, a small fact or small note here. Anyone while they tell you this particular word, segmenting purpose, it's always gonna be unsupervised. So all these segmenting works, like segmenting your foreground picture from your background picture and separating your singer's voice and background, and all these stuff is gonna be unsupervised machine learning. So what is this, guys? Automatically grouping your personal collection photographs into gallery, like what's this exactly? Automatically group your personal collection of photographs in gallery into groups. Come on, guys. What's this? Is it a supervised machine learning or unsupervised machine learning? People, are we here? So it's just like automatically grouping your personal collection of photographs in the gallery into groups. So a ML algorithm in the backstage is what it's gonna do. It's just gonna cluster your similar kind of images together. So this is gonna be unsupervised. Okay, one last easy one. Given a patient's X-ray image, diagnose whether it's cancer or not. Whether it's supervised or unsupervised, guys.
Supervised.
Yeah, exactly. Because
Supervised.
Supervised.
supervised. Cool, cool, cool. Because we need existing data which tells us for this kind of image it's cancer or not, and for another kind of image it's cancer or not. So it's obviously gonna be supervised kind of machine learning to train a model which is able to classify a particular image whether it's cancer or not. So it's gonna be supervised. Okay. So as we just looked into what's supervised machine learning and what's unsupervised machine learning, have you guys ever came across these terms where you where you just get overwhelmed by these terms like binary classification, multi-class classification, regression, and etc. So can any one of you tell me what a binary classification is? It's already up in the screen. So can any one of you tell me what a binary classification is?
in which we only predict two outputs.
Okay, it will just gonna predict two outputs. So basically, guys, when your label space, when the label space in the data set, so just think that we have three features here. So some random data which we have inside this feature, and in our particular label space, if it's just gonna be 0, 1, 0, 1 or 0, 1, or if it's gonna be like our mango case, right? Ripe or raw or ripe, and it's gonna go on. Or another example can be a case of true or false, or another case can be yes, like anything. When you can define this binary classification, when the number of unique label is 2. Guys, got what binary classification is? When the number of unique labels are just 2, we name it as binary classification. Best example would be like classifying a particular object to this or that, or Guys, can you just get what a binary classification is? Okay. Okay, how many of you didn't get what a binary classification is? Raise your hands.
ए यहाँ तुम लोग हद हो सारे ऐसे देखते हो
Some people are not racing for both. Come on, guys. Did you get? How many of you didn't get what a binary classification is? Okay, Path. Yeah, we'll go. We'll give it a shot again. So, looking into what binary classification is again, we just have a data set here, the same mango data set, which is gonna tell us if a mango is ripe or raw, and we have another data set here using the features. It's gonna tell us if a person is old or young, old or young, and we have another data set here which is gonna tell us the if a particular loan can be granted or not granted, granted or not granted. Parth, so just tell me what is the similarity you see between these three data sets which we just wrote right now?
All have features and labels that need to be supervised.
Yeah, they are. There are features and labels, so it is supervised. But when you look in terms of the label only, what are the exact relation you see with these three data sets?
Not sure.
So when you see the relation between these three data sets in term of the labels, we just have two type of labels. Either we have raw or ripe, either we have young or old, either we have grant or not granted. So it's just two, right? Therefore, we name it as binary classification. Got it now?
Yeah.
Okay, cool. So that's why we name it as binary classification. And now, coming to the aspect of multi-class classification, as now you know what binary was, can anyone just shoot out real quick what's multi-class classification is?
The labels will be more than two.
Done. Done, right, guys? The labels will be more than two. I don't think so. We need to go in depth into what multi-class classification was. We don't need explanations, right? So, the number of unique labels in a multi-class classification will be more than two. Now, coming to the major part, what a regression is. Can any one of you guys do you guys have an intuitive idea of what a regression is?
It's find the relationship between two variables, whether they are independent or independent.
Um, Not so close, but okay. So let us take a simple record of a person who's gonna go to market daily. So let's see, let's pick a name, okay? It's just us, right? So I'm gonna take this privilege of picking a name from you guys. Okay, let's just say Arulya, okay? So Arulya is gonna go to market every day and she's gonna purchase she's gonna purchase fruits every day. So Arulya is also at the same time she is like making a note of stuff which she is buying every day. So let's say that Arulya is gonna regularly get apples. Arulya is getting grapes, and what else? Pineapple, and then oranges, and then she notes down the prices. So the first day, the person gets one apple, like, I know grapes we can't get it in terms of numbers, but yeah, guys, like adjust it for this case alone. So it's gonna be 3, and then it's gonna be 4, and then it's gonna be 2, and then she notes down the price, which is gonna come out to be 121. Similarly, she just notes down every day, and every day she just figures out new prices: 140, 130, 110. Someday it turns out to be 90 only. And this particular data goes on for a year. So we have like, so not just a year, so like this particular data goes on for 100 days. So we have 100 entries like this. So we have 100 entries like this. So at this particular point, guys, this number 121, 140, 130, 110, 90, can these numbers be any numbers, guys? Like, while we did the case of binary classification, it was supposed to be just two particular kind of label, right? And while we dealt with the case of multi-class classification, it was just supposed to be confined with the number of classes it was there. But when it comes to the price of a particular thing, or when it comes to age of a particular thing, it can be any number, right? Can I get a yes?
Yeah.
It can be any number. So we can also define regression as when the label is confined between minus infinity to plus infinity. We have a really beautiful word for numbers which fall under minus infinity to plus infinity. What is that, guys? I'm gonna write it here.
Rational,
Yeah. I You are not audible. Like, can you be a bit clear?
rational numbers.
Rational, not rational exactly.
It's a range.
No. Correct me if I'm
Real
wrong.
number.
Isn't it real numbers? Guys, isn't it real numbers?
Yeah,
Yeah. So anything, like any time while you have a case where your labels can be any real number, while your labels can be any real number, it's gonna be a case of regression. So can one of you guys like tell me a really potential case of a regression? Can you just come up with a regression case?
House price.
House price prediction. Cool. Really good, Suryansh. Anything else? Anything else, guys?
Wine quality testing.
Wine quality testing. Good. Wine quality testing. Yeah, but if you take the wine's quality to be good or bad, or if it's gonna have three levels of classification like good, medium, bad, or if you're gonna add a average to it, good, average, medium, and bad, it's gonna become a classification problem rather than a regression problem. So I don't think so that will really count.
Yeah, right.
Yeah. So, guys, have you right now? Do you have an intuitive idea between the difference between classification and regression? Can I get a hand raised right now? Abhay, what about you? Sandeep, Sandeepan, are you clear with what regression is exactly?
Yeah,
Just to summarize right now, regression is a problem, or regression is an approach in machine learning while your label space is confined into a situation of minus infinity to plus infinity, which is nothing but your label can be any real numbers. So any real numbers, while you have this type of constraint in your feature label pair, So that is called, that particular scenario, you name it as regressions. Okay. So that's what which we saw right now. So we just saw what regression is in terms of basic terms. So guys, you have to, as like you guys are like stepping into machine learning and you guys are going to do a lot of stuff on the upcoming tenure on machine learning. I just want you guys to like have this as a thumb rule. A machine learning model must aim be a result of memorization, rather it must be a result of generalization. Guys, you can take a screenshot of this particular rule right now. Like this is gonna be your thumb rule till the end of the tenure. So a machine learning model must not be any case of memorization. It must be a case of generalization. So I know right now when I just shoot words like memorization and generalization, it's gonna be really vague. But in just few more minutes, you're gonna just understand what memorization is and what generalization is right away. So let us just look into the picture of what memorization is and what generalization is. Okay. So we just saw that Arulya is gonna go to this uh, market and she's gonna get these fruits. So guys, how do you think we'll be able to predict these prices? Do you guys have a intuitive idea of how we are going to predict these prices while she comes up with a really new price of a really new combination of three apples, three grapes, four pineapples and zero oranges? The machine, this is going to be the input and the ML model needs to predict out the price. How we are gonna execute this particular process? Anyone has any idea like how we are gonna execute this process?
I'll put into a function, then adjust weights and biases, then
Mm-hmm.
we'll predict the price.
Mm-hmm. Cool. So you're gonna put it into a function, right? But that particular function f of x needs to be built upon, right? We need to build this particular function such that the function will work in a way that it will predict the price. But how are we gonna build this function?
We can do this by algebra and like using variables. Like we'll apply variables to all the different fruits, and then
Hmm.
like four we'll take four equations, and then
Mm-hmm.
the four variables can be solved.
Hmm.
So the
That
price of a single fruit can be reduced from that.
cool. The price of a single variable can be referred from that. Arulya, that was a really good intuitive approach. That's how we are gonna go through. But before that, guys, we just discussed few words like the feature space. Can anyone tell me what's feature space again? Okay, just tell me what the feature space or the feature dimension of this particular data, which we are seeing right now. What's the dimension of this particular data? Feature dimension of this particular data. Four, isn't it?
Yeah,
Cool. So the feature dimension of this particular data is gonna be four. So while we write feature space, we're gonna tell it to be r to the power 4. Am I correct?
yeah,
So the label space is just gonna be r. This is how we are gonna represent our particular stuff henceforth. So the label set is gonna be r, and the feature set, the label space is gonna be r, and the feature space is gonna be r to the power 4. So a particular example, like we can say, it's gonna be like 3, 4, 5, and 6. This will be apples, grapes, pineapples, and oranges. Will this be the subset of r to the power 4? You get right. So in this particular combination of a feature space which has r to the power 4, this can be a subset of it. Can it be?
Yeah.
So this particular test case can be a subset of r to the power 4. So guys, what was the initial explanation which I gave to you regarding machine learning? I just told you that we need to derive a function out of the entire process and we need to figure out a function out of the entire process. That was machine learning. So our end goal will be, we need to figure out a function h in such a way that this feature r to the power d will get mapped to r, isn't it? Where h will be the function, r to the power d will be your label, sorry, features, r will be your label. So you might just ask me, what's d? D is nothing but the dimension. Are we good till this part? So we are just gonna figure out a function h such a way that h will be able to map r power d to r, which is nothing but you're gonna map your features with labels. Are we fine with this particular part, guys? Can I get a raise of hands? Nice. So this is gonna how we are gonna like exactly this particular deriving our end product h is how we are gonna exactly go through the phase right now. So at this particular part, to work upon of deriving our particular h, we need to have a measure of how our particular h is gonna work. So we can also tell this error as squared error. So what's gonna be our square data? H of x minus y the whole square. So you might just be like confused right now, what's gonna be h of x and what's gonna be y. So I'll just tell you. So I just told you that h is gonna be a function, right? H is gonna be a function. So h of x will be the result of the function. Guys, is it a yes? If h is a function, while we give a input to h of x, it will be the result of a function. Guys, can I get a single s?
Yes.
Yeah.
Okay. So here h of x is gonna be the output of the function, and y is gonna be your original value. So how to clear it off right now? So if suppose we have a combination of 1, 3, 4, and 2, we have our original data to be 121. So how this thing is gonna work right now? If it's gonna be h of what's here, 1, 3, 4, 1, 3, 4, and 2, right? So if it's gonna be h of 1, 3, 4, and 2, the y value must be equal to 121, right? 121. So obviously, while we train a machine learning model, the output of this will be differed from the original value. So while we squared this particular output, we get our loss function known as squared error. So guys, are we clear with what squared error is right now? Guys, is those doubts or are those clear points? Like, are we okay? People who are clear with squared error can raise their hands. Nile, do we have an issue with square errors?
Yeah,
Uh,
can you explain that once again?
okay, cool. So,
No.
Arulya, we just had a case like where, I'm sorry, just give me a second. So, we just had a case where we saw this particular thing, right? We saw that if you go buy um, one apple, three grapes, four pineapples, and two oranges, the price will turn out to be 121. So, this 1, 3, 4, and 2 are your feature, and this 121 is your label. So your label is the original value, isn't it?
Yeah.
So your label is your original value. So what happens here is that the same thing which we have done. What I have told here, h is the function which is gonna be extracted out of the machine learning process, isn't it? So while we feed this data of 1, 3, 4, and 2 inside this h function, which we have generated right now. So h is a function which we have modeled, and h is the function which we have generated out of the machine learning process. So when you feed this 1, 3, 4, 2 test case inside this particular h, it will just give out a value of suppose 90, and but the original value which is y turns out to be 121. So there will be a particular difference here between 121 minus 90. So it will be 90 minus 121. So what we are going to do is that we are going to square this 90 minus 121, and we will get an answer. And this answer turns out to be a metric of squared error.
Yeah, understood.
Okay, cool. Anyone, guys, it's clear, right? Like what squared error is. Can I get a hand raise right now? I guess Abhishek and Sandeep and Nile, everyone, it's clear. Okay, cool. So that's what is squared error is. So this squared error, we are taking a metric because we need to know how our machine learning model performs, right? So we need something called the squared error. So using the squared error, we are gonna measure our machine learning model, how it's gonna perform and at what level it is and all. So what do you think a good machine learning model must be? Should it have a high squared error or should it have a low squared error? Tell me, guys.
Low squared
Low.
error.
Low squared error, correct. But how low should this squared error be? Say, what is the lowest point which we know in terms of natural numbers?
Zero.
What's 0? So, guys, can I get this intuition from everyone that we are trying to pull down our squared error to 0? Is it true?
Yeah, it's true.
Yeah. So we are trying to pull down our squared error to 0. So what we are trying to do is that, so just tell me at what case will be the squared error be 0 if the squared error has this particular formula? At what case will be the squared error be 0? What must be the value of h of x and y such that the squared error will be 0?
They should be equal.
They should be equal. That's correct. So h of x, sorry. So h of x must be equal to y such that this squared error value turns out to be 0. Isn't it true, guys?
Yeah.
But just just pause and think about this particular case where h of x must be equal to y. What will just happen? You are just gonna go into a case of memorization, and if you guys have heard about these words like overfit, memorization, etc. Like, guys, did you just remember the thumb rule which I told you before we just started off this regression? What was the thumb rule, guys? Can anyone tell me the thumb rule? A machine learning model must not be a result of memorization, rather, it must be a result of generalization. But you can ask me why, if h of x is equal to 0, it turns out to be a overfit or it turns out to be a memorization. Like, because I'm the one who just told you that the h of x, like the entire squared error must turn out to be 0 or turn out to be a minimum. But why is that a really worst case? Like, why memorization is really bad? I'll tell you why memorization is really bad. So at this particular case, with one apple, three grapes, four pineapples, and two oranges, the price turns out to be 121. And for another case with three apples, four grapes, five pineapples, and two oranges, the price turns out to be 110. So we just talked about a case where our h of x must be exactly equal to the y value. So whatever a machine learning model predicts, prediction must be exactly be equal to actual. This is a really bad blender to do. We should never expect this particular case, because when our machine learning model will be at a position to exactly predict the actual, it is just gonna memorize this entire table and it's gonna vomit it at the prediction. For example, in terms of machine learning, while you go ahead, we will look into a case of overfitting. For right now, you can take this case of overfitting. What does overfitting does? Overfitting is a case of memorization. So you like, guys, did we just got what memorization is right now? Memorizing and our machine learning model turning out to be really bad. Can I get hand raised from you guys? How many of you guys want me to explain the concept of memorization again? Okay, I'll just summarize memorization once more time. Just because we wanted our error to turn out to be 0, we also wanted prediction to be exactly our prediction to be exactly equivalent to the actual value. But that is a really wrong approach to do. If we train such an algorithm, that particular algorithm is gonna memorize the entire data set, and it will, like, it's gonna exactly be like, say if it's gonna be 1342, I will give 121. If it's gonna be 3452, I'm gonna give 110. So this is how the machine learning model is gonna work, and we really don't want it to work in such a way. We just gonna go to a generalization approach. We're gonna go into a generalization approach. But how are we going to generalize this particular term? So as one of the members here just mentioned that we can introduce variables, we can use algebraic terms. That's so true. So guys, can we develop a equation where price will be equal to x1 w1 plus x2 w2 plus x3 w3, where x1 will be the number of apples, x2 will be the number of pineapples, and x3 will be the number of oranges. Guys, can I get a S?
Yes.
So
Yes.
yeah. So at any given time, only if I know the W1, W2, and W3, I'll be able to easily predict my price given the number of apples, number of pineapples, and number of oranges. Isn't it true, guys? Only if I know W1, W2, and W3, I'll be able to predict the price, isn't it?
Yeah.
So what we are trying to do here is that here we are trying to do a generalization. So at a particular point, if you have the W1, W2, and W3 with you constantly, at any particular time while a person introduces you x1, x2, and x3, which are your features, you will be easily able to predict the price, which is your target. So this particular thing can be rewritten as can be rewritten as h of x is equal to x1 w1 plus x2 w2 plus x3 w3 plus it goes on till xn wn. Guys, do we have an intuitive approach right now? This h of x is gonna be our machine learning model, and all xn is gonna be our features. And what are this w? Do you guys have an answer? What is this w which we are generalizing upon?
The number of fruits.
The number of fruits is the xn, right? Xn is the
Okay.
number of fruits. So each and every time x1 is gonna be apples, each x2 is gonna be the number of bananas, x3 is gonna be the
The
number of
price of each fruit
the
of a
price
single
of
fruit.
each fruit. But at this particular instance, we are not going to be updated with the price of each fruit every day. But an intuitive approach is that x1, x2, x3, like this w1, w2, w3 will be the price of each fruits. But what if we don't get updated with the price of each fruits? What are this w1, w2, w3, wn gonna be? So, introducing a really important term to you guys right now. This W series is gonna be your weights. Whatever we have found in terms of W is gonna be weights. And what is this H of X? H of X is the machine learning model which we are supposed to train, isn't it? So, at the end of the training process, which we just saw here right now, where a data set has features and labels, and the features and labels are put through a learning process, and we have a particular model, right? We are the end product model is nothing but finding the weights. So what we do while we pass our data set into a learning process, the learning process helps us to find out the weight. So these weights will be constants. So these weights will be constants. Guys, did you just get the idea of what weights is exactly? Weights is used for generalization, generalization, and it's the end product, end product of a ML training, and also it's the weights which help us to predict. Guys, did we just get what w1, w2, w3, wn are, and what is weights exactly?
Actually, weights is the importance we give to each feature and how much they're gonna
Exactly.
contribute to our level.
Yeah, how much they are going to contribute to our label, but how are we going to find that? How are we going to find that? And how much each label is going to contribute to the final regression is what we spend all our efforts on, and it's what we are modeling, right? Guys, do you want me to go through weights again once more?
No, no, it's fine.
Okay. So, looking into this equation which we saw just now, where we just saw what weights is exactly. So, this can also be written as h of x into x1, x2, x3 into the matrix of w1, w2, w3. Will this work? Like, you know it, right, guys? So the result is gonna be x1 into w1, x2 into w2, and x3 into w3, which will again result in the previous equation. So can we say this in this particular terms? Can this be written like this?
Yeah.
So this particular term can be written like this. This can also be written in this particular way, right? This can also be written as w1, w2, w3 into x1, x2, and x3. This can also be written in this term. So what this term is, this is a particular matrix and this is a particular matrix. So this entire term can be represented as h of x is equal to weight transpose into x. So this entire thing, whatever we are trying to derive out of, like whatever machine learning model which we are going to train in terms of regression, it's going to be in terms of weight transpose into xn. So we just also saw a squared sum of squared error equation. So according to that, if we just say, we just saw that it's going to be h of x minus y the whole square, isn't it? This will be the sum of squares. This will be sum of squares which we saw. So having the h of x value, can we substitute this particular thing inside this? So it is gonna be your like it can be represented as f of w is gonna be summation of I is equal to 1 to m w transpose xi minus yi the whole square. So you may find this particular equation to be pretty clumsy, but just try to grasp it. This W transpose Xi is the weight and feature combination, which is going to be our model's output. And this is going to be our actual value, actual, and then this is the predicted value, where these stuff are going to range from all the entries which we have, which is going to be from 1 to m. Can you guys understand this particular equation? Guys, were you able to understand that particular equation which we saw at the last right now? Abhishek. What about Nile, Suryans, Abhishek, Sandeep? Do you want me to explain that particular equation again? Suryansh, are you here? Abhay, do you want me to explain the pretty last equation which we saw again? Okay. So, see, Abhay, just look into this case where the WTXI, which we saw as the model prediction, which we saw as models prediction,
Yeah.
and yi will be the actual value. Okay. So prediction minus actual will be your error, Isn't it correct?
Yeah.
So that's what we are representing here. Earlier we represented as h of x minus yi. Here we are representing as wt xi minus yi. That's it. So we
Okay, understood.
so right now can we reduce the error, guys? Right now, if we reduce this particular function f of w, will we reach the goal of reducing the error? Can I get a yes?
Yeah,
So
I
as I
guess.
asked this question before to you guys of reducing a error, can we reduce the error right now? So what we have to do at this particular case is that we have to find the minimum of f of w. We have to find the minimum of f of w. Guys, have you just go back to your 12th standard or your M1, your first semester max time? How do we find the minima of a particular graph? Do you guys have? Do you guys just remember how do we find the minima of a particular graph?
We differentiate it.
And then we equate it with zero.
Yeah.
We differentiate it first, and then we equate it with zero. Do you guys remember this particular symbol, gradient ka symbol?
Yes.
Yes.
So if we differentiate, if we take gradient of f of w, we are gonna get some complex equation which I'm gonna write it for this particular case. But guys, this is not exactly required for you. It's gonna be w transpose into summation of I is equal to 1 to m, where this particular value is gonna last from last between xi and xi transpose matrix along with minus of I is equal to 1 to m xi yi. So what, just don't get like what's that really serious about this right now. I'll just tell you what it is exactly. So we just saw this particular equation of f of w, right? So we just saw a error equation. So you guys told me that to, if we differentiate and equate it with zero, we will get the minimum of this particular error. So while we differentiate this particular f of w, we, it turns out that the result of the differentiation is gonna be this. Okay, done. You just got why we got this such a complex equation out of differentiation.
Yeah.
So after we differentiate, we are going to equate this particular equation with 0. Equating it to 0. Correct? Only if we equate it with 0, we will be getting the minima of the particular graph. And minima of the graph, which means minima of the error, isn't it? So if we equate it with 0, it's going to be W transpose into summation of I is equal to 1 to M xi x transpose minus summation of I is equal to 1 to M xi yi equal to 0, isn't it? Guys, can I get a yes? Guys, nothing. See, we have taken this particular value out of the differentiation and we have equated it with 0 and we have written it below. That's all.
Yeah.
So that's good. So what we have done is that we have done that particular part and we have equated with 0. Now, guys, I just need you guys to focus on this single equation only. Here, what is WT, which we have shown right now? Like, what is W in terms? Any one of you can answer. What's W? Like, I just told you about weights and all right now. So, what's W?
Weight transpose.
Yeah, weight transpose. WT is weight transpose. So, your W is going to be your weight. So, while we looked into our part of H of X, H of X was nothing but our weight transports into Xi, isn't it? So
Yes.
only if we find the weight transpose, we will be able to do a prediction, isn't it? So we just need to find the weight transpose. So what I can do is that except for the weight, I can move all these things to the other side, isn't it? I can first take this term, put it into other side, and then put this term in division with respect to the other term. Can I do that?
Yeah.
So after doing all those complex mathematics, we will arrive at a particular term where we will get a really special weight. So that weight will be W star. This W star will be equal to summation of I is equal to 1 to M xi x transpose the pseudo inverse into summation of I is equal to 1 to M of xi yi. So such a weight. So when you just find such a weight, this weight, this W is not going to be just a W. This W is going to be an entire matrix of W1, W2, blah 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 till Wn. Will it be? So while you find this particular W, while you find this particular W is gonna be your end product, or this particular W is gonna be your end weight. So W star is the most optimized weight, or this W star will be your W1, W2, W3, W4 if it is a 4 feature space. So when this W is used with the prediction of 1 apples, 3 mangoes, 4 bananas, and 0 oranges, we will get a price of something. We will get some price while we find the W1, W2, W3, W4. Guys, did you just get an intuitive idea of how the weights work in ML? Like, can I get hand raise? Okay, 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 okay. Nile, is it good? Did you just get an idea of how weights exactly work?
I had a doubt like
Yeah,
previously what we calculated the W function. So
yeah.
what's that? The
This
function of
W
W,
function, right?
it
This
is
W
known as.
function, the W star.
No, no, the above
This
function
one.
of W, f of W.
Okay, this
Yeah,
f of
like what
W.
it's known.
Before the gradient.
Yeah,
So f of W is a function which has. Okay, I'll tell you this particular part. F of W, W transpose xi minus yi. What's W transpose xi? W transpose xi was our machine learning function which we need to find out.
yeah,
Why was it W transpose xi? It was W transpose xi because it was x1 y1 x2 y2 x3 y3, which we separated into like matrix form, which was w1 w2 w3 into x1 x2 and x3, while this
yeah,
matrix form was written in terms of W transpose xi, isn't it?
yeah.
So W transpose xi will be the result of the prediction,
Okay,
and yi will be the actual value.
yeah. So
So
like what do you call the f of W function? Like,
oh, why you are just telling me why did we call it as f of W?
yeah, like
So
what is.
yeah, mathematically, while you need to work upon W,
Okay,
so yeah, here all these gradient operation we did not do in terms of x, isn't it? We did those operations in terms of W. So For the convenience, we have taken it as f of w such that we can minimize it with respect to weights.
Yeah, got it.
So we did that particular part, and then we minimized f of w. And in the process of minimizing f of w, we just first took the differentiation, which is the gradient of f of w, which turns out to be a really clumsy equation. And we equated the result of the clumsy equation with respect to zero, where we found when we equated that result to zero, we did just simple algebra where we found out f w transpose, where w transpose, this W transpose where it's in the minimum is known as W star. W star is the best and the most optimized weight, while we get the output of the machine learning, which turns out to be another horrible equation. But when we solve this horrible equation using computation, we will get the price of price of a particular test case. Guys, are we good with this particular part? Okay, Suryansh. Okay. 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 So all these things which we all these things which we did right now, right? All those stuff, these complex mathematics, all these stuff which we did right now. In what does in how fast you guys do it? You guys do it in terms of like you guys do it in terms of model dot fit. This particular command includes the entire process whatever we did right now. So whenever you give this model.fit, what happens? It goes on with this comprehensive max in backend, and what it does, it finds out the best weights and then it fits the model inside that particular thing. So how many of you have did that model.fit? I guess most of you guys would have done model.fit here. Can I get hand raised? Like how many of you guys like have just executed that command model.fit? I expect, I guess Suryan should have done model.fit. Yeah. I guess Nile would have done. Okay. So those model.fit, what it happens, you are basically fitting the model. You're basically training the model. And as I've told you in the training phase, you are going to learn your weights. What does learning your weight means? Learning your weight means going through all these mathematical things which is going on in your in your particular program, and it computes your weights such that you will be able to, such that this weights will be learned and kept for any time use. So when you save a particular model, what you are doing is that you are just saving your weights also. So while you save your weights in future, you are just gonna do simple algebra with the weights and you're gonna get the predictions outside. So that was what weight was all about. But was this all worth it? Like, was this all worth it? Because like when we come in terms of a simple linear regression, can anyone of you guys tell me what's the equation of a straight line? Guys,
X
can you,
equals to Y.
Y equals mx plus c.
y is equal to
MX
mx
plus
plus c?
C.
Yeah, is it there in this place here right now? So what are m and c here? Can anyone tell me what are m and c respectively?
M is the slope, c is the intercept.
M is the slope and c is the intercept, isn't it? So at this particular case, what determines the line here? What determines the shape, like what determines the angle of the, what determines the angle of the line? A line can be like this also, a line can be like this also, a line can be like at what's that, this particular fashion also. Like it's all based on the m and c value, right? Like how a line is oriented and where the line starts and where the line ends. Like all these things depends on m and c only, isn't it? Can I get a yes?
Yeah.
So all these points are basically dependent on your m and c value only, isn't it? So at this particular point we can say that this y is equal to mx plus this y is equal to mx plus c. This y is equal to mx plus c. We can write it as y is equal to mc matrix into x into 1 matrix. Can anyone take this further? Like what I'm trying to say out of this? Can anyone do? Anyone just got the intuitive idea right now? What is it gonna be? Guys, do you get why I wrote it as mc into x and 1? It's definitely gonna be m into x, which is gonna be mx, and c into 1, which is gonna be c. So it can be written as y is equal to mc into x into 1. Isn't it true? A straight line can be represented in this fashion. Guys,
Yeah.
so if we compare this particular thing with something else, which was h of x is equal to w1 w2 into x1 x2. What is the weight here, guys? What's the weight?
M and C.
M and C. Correct. So right now, M and C here can be compared with W1, W2 here, and X1, X2 can be compared as the feature X1 and X2 here. That's really true, right? That's really true in case of a straight line also. Like we can say that anytime when a number, if we take a number to be if we take a number to be 1, so when the number 1 is mapped to this particular line, it will give a particular y. So it will be on this particular line. When number 2 is given inside this particular function, it will map to a particular y value. So it will be on this particular line. So just with the help of m and c, we are able to figure out this entire line, isn't it? So did you just get the intuition behind the linear regressions idea behind this MNC, and or just between the comparison of MNC and W1 and W2? Can I get a hand raise? Does anyone have a doubt between the linear regression? So what you saw just now with the straight line of y is equal to mc and m and c here, and m and c being the weights, is exactly your simple linear regression. Congratulations, guys! You have just learned your first machine learning algorithm completely. So it's too late right now. So guys, I guess I have to stop here. So we had planned something called the concept of bias and variance and all to teach you guys, but it's already 2 hours session right now. So I guess, yeah, many people left too, so I won't be able to fully complete bias and variance. How many of you guys want to have a little glimpse of that particular topic also? Or how many? Okay, how many of you guys want to end this session? I know it's getting long right now. Okay, how many of you guys want to learn bias and variance also before we go? Can I get a hand raise for bias and variance right now? Okay. So let's just see the diagram of bias and variance, and let's just end the topic with this. So when you look at bias and when you look at variance, so can anyone tell me, do anyone have idea of what bias is and what variance is? Okay, I'll just tell you. So basically, when we have a low variance and a low bias, we are very near to the intuitively, we are very near to the target. When we have a low variance and we have a high bias in the sense we are we are extremely missing the target a lot. So when you shoot a bullet into a particular target with a high bias, you are like shooting it very away from the target point. So it can be said that our particular predictions are really away from the particular actual output. So prediction and actual output such that the error is too much high. So we can say that the model is highly biased, or we can say there is a high bias in it. So how do we say high variance? So each and every time when you predict something, so it's like each and every time you shoot at a particular target, you are going to shoot at different places. So we are just saying that your prediction is varying so much. There is a high variance in your prediction, which means that you don't have a consistent prediction at a particular point. So our variance is too high. But what means that if we have a high bias and a high variance, we are having extreme error difference also. And at the same time, we don't have a constant point of prediction. We have a high variance in prediction. Just I just want you to look into these graphs again. I just want you to look into these graphs once more, such that you will have an intuitive idea of what is variance and bias. So variance is nothing but how much amount the scatterness is there in your prediction, and your bias is how much away the predictions are there from the actual. So is it fine, guys? Like we need some more time to deal with all these stuff, but still, yeah. So great, guys. You have just completed your introduction to machine learning 101. And yeah, we have a lot of stuff coming for you again. And yes, guys, like I would really love to get feedbacks from you right now regarding the session. So I'll just note these names. Actually, you guys gonna really get through a lot. It's gonna be Aryan, Arulya, Abhilesh, Abhishek, Suryansh, Sandeepan, and Mile. I really appreciate your patience a lot. Thank you so much for waiting till the end and like really supporting a lot. So, do you guys have any doubts with this session? Can you just speak up?
Where can we learn more about it, like neural networks and all in depth?
I get it. So, see, just don't be in a urge to jump into neural networks. Just now we have just now we have completed the area of what's that? Um like the basic crux of machine learning. So we need to get inside a really depth of like more algorithms. We need to take you to particular procedures before you really get into neural learning. Aryan, I guess Aryan asked the question about neural learning, right? So neural network. So this was one of the mistakes which I did in the early stages when I directly jumped into the core mathematics. See, Aryan, you can learn networks, you can implement it, you can even train good models out of it, but you will do stuff without understanding it. And doing stuff without knowing what is exactly happening in behind is really vain. Like you need not do stuff like that. Like go step by step, complete proper machine learning, and then head on into neural networks. Like we'll give you what's that proper documentations of how we are gonna do everything. So yeah, let's go on with the flow.